talking about build and test wait time, right? So there's a mechanism called build caching. So build caching is very different from dependency caching. That's a typical confusion, right? Dependency cache represents a dependency you have on another source repository, right? And a build cache actually is much more fine-grained, and a build cache caches the result of a single build action. Could be a Gradle task, a Maven goal, compile, test, check style, Java doc, whatever it is, right? And when you run a build, right, which is typically a multi-module build, how many submodules do you have in your Gradle build?
It's over 200.
Over 200. So when you run a Gradle build, we're probably in average talking about 2,000, 3,000 Gradle tasks that are executed as part of that build, right? Maven is it's very similar. So now imagine a build cache is able to cache the results of most of those build actions. So you now have a cache that caches 2,000 different steps of that build, or 3,000 different steps, and the build cache is able to identify whether any of those inputs have changed the next time you run the build, and if they haven't changed, then the result from that build cache is used and the build action is not run. Yeah, sounds like a great idea, huh?
Yeah, of course. I mean, so there's kind of two things at play here, right? If you want to reduce your build feedback times, you really have two options. You can do more work in parallel, and then you can just do less work overall. So sometimes parallelizing, right, and just like any other piece of software, scaling horizontally is tricky and difficult, and you can only do it to a certain degree, find these sort of logical chunks of the project to split up. So the other big aspect is, well, let's not do a bunch of work that we just did, 10 minutes ago or whatever it was, or even a day ago or a week ago. Since it's very obvious that if we just ran the whole 2-hour-long integration test suite and I merge in a change that's just a simple functional change to one plugin or module, then why test the whole core functionality again, right? It's both costly in the sense that my feedback time is longer because I'm now waiting to test a bunch of stuff which I know that my change has no behavioral impact on that, right? Because we can identify dependencies to do that. And because flaky tests are a thing that will never go away, there's now a likelihood that not only am I spending time to execute a test suite, which I know has no relevance to the change I made, but there's now the possibility that will fail, and now, and then the whole build comes to a stop, and I have to re-trigger it to get a successful pass on some code that I didn't modify, right? So that was the big one for us, almost even more so than the feedback changes. We obviously want to get those feedback loops quicker, but it's sort of one of the things we can do to address these long and some unstable test implementations is to just run the tests less often, right? So you just sort of naturally reduce the possibility of that happening.
Would you be concerned that it also hides flaky tests, or they still show their ugly face often enough that you can identify them?
You're going to notice if you have rats in the house without it being without it being a plague, right? You're going to see. So there wasn't much of a risk of well, now we'll never know. Those tests do happen, right? So that wasn't a big concern.
Yeah. Good, that's good, and that's a really interesting aspect of it. And I guess CI cost was also a part of the savings you get from those. Is also at least the benefit you do not mind.
Yeah, that's almost just bonus points.
So basically, right, for all the 68% that said I want faster build and test time, right, there is no way around build caching. I think it's like getting an SSD drive in your computer, right? It's like that kind of level that probably hardly anything else will ever give you such a boost for your build and test time for most projects, right, than a build cache.
Yeah, you just have to be more intelligent about it, right? You can only throw resources at it that only scales so far. The kind of interesting about the build cache is that it almost scales differently than the size of your code base, because realistically, if you had a really well modular piece of software, then you can almost scale kind of infinitely with this idea that, well, one single change set is going to be relatively focused, right?
Yes.
So where I could have a project that's 10,000 submodules and hundreds of thousands of tests, but if you have it engineered in such a way as that any single change maybe runs a very small subset of that, then you don't have this issue where your build times sort of grow linearly with the complexity of your software.
I would like to kind of reflect a little bit upon that, right? So what you're saying, right, when you throw resources at it, right, as your code base grows, when you don't build smarter, when your code base grows exponentially, the resources you need the resource needs will also grow exponentially. But a build cache, right, and we have some interesting data, right? When we talk with some of the folks who have large monorepos, 1,000 or 1,500 submodules, with the data we get from them, they say half of those submodules are leaf modules. No other module depends on them. And then it's exactly what you're saying, right? The cost of building them is now proportional by 1/10 of the overall build time. Right.
So you could effectively add any number of those and not really affect or really dramatically affect the productivity of everyone else on the team.
Yeah, so cool. That's why I think this is a must-have. So I think the second pain point was inefficient debugging of build, test, and CI failure. So has that been something that was problematic, and how did you manage to improve that?
One of the problems we had was, with identifying these test failures and this flakiness, right, where we just kind of have this sort of fire hose of notification emails from Jenkins saying this thing failed, this thing failed, this thing failed. And so the way we actually deal with this on the Elasticsearch team is, if the developer productivity team was solely responsible for this, they would get nothing else done, right? Like if you just had them, their job is to just watch, babysit CI and deal with build failures, we wouldn't be able to make any progress on developer productivity because we would just be spending 100% of our time on that. So what we do is we effectively have an engineer who's sort of on shift every day. Every day there's a different person who their job is to triage these failures, because many of them aren't associated with a particular commit, right? Those, we'll send to, hey, you just merged this, something failed, can you take a look as a deal with your changes? But we have these other large regression suites that run every 8 or 12 hours that might have 12 hours worth of commits in them. So it's not practical or really reasonable to spam half the engineering team saying, hey, these 10 build fails, it could be any one of you, right?
Yes.
And it's just not really an efficient way of triaging that. So we have someone that does that. And part of that is providing them some tooling to make that job easier, right? Just saying, well, here's the Jenkins console log. Good luck isn't ideal. So we found that while we were doing that, the folks that were doing that job just didn't find that they were being particularly effective. We had data all over the place. We're sending test failure data to sort of an Elasticsearch cluster they can search, and they have the logs, and then they have some other the JUnit reports or whatever. So it's just kind of this disjointed mess of data that they have to go to a bunch of different places to get the context for this failure and then try and look it up. So folks found that they just felt that they weren't really productive doing that job, and they found that come the end of the day, if let's say 50 failures came in, they were really only able to really dig into a small percentage of them because it took so much time to go and find the information they need. So we found that folks didn't have enough information to really dig deep into the issues that if you gave them the tooling and the context to see, oh, hey, this thing's failed, 5 times today, and it hasn't failed in the last month, that's probably something you should spend your time looking into versus something that just kind of came by, something timed out, it happened once in the last, 6 months, don't spend all day on it, right? And so giving folks that context, those tools to be able to kind of make those decisions on how to prioritize their time while they're dealing with these failures better has made a big difference.
So to summarize that, right? So it's 2 elements from what I understood. One is basically a comprehensive set of data that is explorable, right? To understand the root cause of something, but then also have higher level data to show you, hey, this is how often that particular incident happened and when it happened, so that you can prioritize, because otherwise it's just failures, but how do you know how to prioritize those 60 failures, right? So have data around that. And
in most cases that's more important, right?
Yes.
So it kind of depends. If I submit a pull request and I get a notification saying one of my checks failed, I want to go, okay, what test failed? Let me go see, because it's more than likely it's related to the changes I made. But if I'm triaging test failures and I get a random failure that's from maybe some functional area of the software that I'm not familiar with, it's a different area team or something like that, realistically looking at the details of the failure, it's very often just not obvious to a random person on the engineering team, what that might be related to. Okay, well, that's in this test, and that's so-and-so's area, and they're kind of working on this. Maybe I can figure it out. But by looking at the context and saying, okay, well, what's the history of this test? What's going on? Oh, hey, this was a brand new test that was added to the code base yesterday. That's an important thing to know, and that's really indicative of maybe something's going on. So one's kind of the tactical level of insight, and one's a more sort of strategic level, which is really important when you're talking about having someone just, hey, your job today is to look at test failures, and they might be from any part of the code base, many parts of the code base you're not familiar with, but you're sort of expected to make some kind of a decision, at least point it in the right direction, and make action on it. Open an issue, maybe mute the test if you know it's causing problems, things like that.
Two more questions on that subject. So one would be, what about you are such a distributed team, and you also collect this comprehensive set of data for the people running local builds, right? Is that also something you have an eye on, or are you mostly focused on CI?
Mainly focused on CI in terms of sort of keeping things green. Local build failures are sort of expected to happen, right? Like if I see a test failure from a local build, or even from a pull request build, that it's almost expected, right? Well, the point of that is to catch a failure. If our sort of regression test builds have failures, that means something slipped through a quality gate.
Let's say you see out of a sudden null pointer exceptions in local builds,
so it depends on the nature of the build failures, right? If we have build failures for non-verification type reasons for local builds, that does indicate.
And you pay an eye also on what the local experience is.
Keep an eye on basically all those. We kind of triage those. It's like, on Monday, so on the last week, what was the top reason? Because those are kind of issues that kind of come and go. It's like, oh, something's wrong with our Docker tooling, and our Docker builds are exploding all over the place. We'll need to nip that. And also in terms of just local debugging, obviously our engineers use that.
Yes, they use it themselves, right? So there's a lot of self-service that also comes with that, right?
And we've sort of educated the team very well. So if you reach out to develop, the build engineering team, and you don't send me a link to a build scan, you need to send me a link to a build scan.
So one thing I just wanted to also reflect a little bit upon, right? What I really like with how you're doing things, right, is that it's not like, there is this group of people who we throw all failures at, and they have to figure it out, because that is probably the best way to lose your most talented developer productivity engineers, right? If that is what you're doing, right, for 1-2 years, then at one point you might say life is a little bit too short than just babysit CI failures, right? So there's even that aspect here that is something that really should be shared, right, across the whole engineering team.
Yeah, and it has to be, right? There's just no way to reasonably scale that, right? If your job is just looking at read emails from Jenkins all day, every day after day, that's going to get old real quick.